All right, so we're going to do notes and examples for lesson 5, empirical versus molecular. You should have your bell ringer and your attendance done. Let's kind of discuss these. We're going to go ahead and go to our notebook and get our notes going. I'm going to title it, just like we have been doing, moles 5. And we're going to go empirical versus molecular. All right. A lot of times we start out and we just kind of think about what do these words mean to us, but in this case, it's not quite that straightforward. The empirical formula is the reduced form. So it's kind of thinking about lowest common denominator, kind of thinking about how can, like when you reduced fractions, you had to get them down to the smallest numbers. Whereas the molecular formula is as it actually exists. As it exists in real life. Okay, so as it exists in real life versus the reduced formula. They have, what they have in common is that they have the same ratio of elements to elements. So let's look at some examples. Okay, on the empirical side, I'll go ahead and rewrite it so that we're very clear. If the formula I'm looking at is P2O5, that's the ratio that I have between the phosphorus and the oxygen. But the molecular formula, so how it actually exists in nature, might be P4O10. So you can see that the empirical formula, is the reduced form. Okay. All right, so let's look at another example. Let's look at a molecular formula. If I have C10H22, what is my empirical formula for that? How could I reduce those numbers? If I divide them both by 2, I'm going to get C5H11, and that is the empirical formula. So you want to remember that this empirical formula is a ratio of element to element. Okay, let's look at a couple other ones. If I have a molecular formula of C6H18O3, what is my empirical formula? If I divide all these by 3, which is the smallest number over here, I'm going to get, C, C2H6O. So let's look at another one. If this is my molecular formula, C5H12O, can I reduce that any? No. And so this is also, so we want to probably make a note of that. This cannot be reduced. So they are the same. The empirical and the molecular formula are the same if it cannot be reduced. All right. And that'll happen sometimes. Give me a thumbs up if that makes sense. And you're like, got it. Okay. So these vocab words, that's going to roll into the math that we have to do. Okay. All right. So some of you who kind of got into the lesson earlier might have seen that we have a note page and that we have a worksheet page that we can follow along with. I'm going to pull up that note page. We've already kind of talked through the first part, and we're going to look at example 1 and 2 together because these are pretty good examples of what you might see in problems that you have to do. So I'm going to kind of walk you through that and show you what is expected, okay, as we do these problems. So example 1, if I could write an E. Example 1, let's look at this. A compound was analyzed and found to contain 13.5 grams of calcium, 10.8 grams of oxygen, and 0.675 grams of hydrogen. What is the empirical formula of the compound? Okay, so I don't know about you guys, but sometimes when I read that, it almost makes me glaze over. There's so much numbers and words in there. So what is it asking us? It says, what is the empirical formula of the compound? So we're going to find the empirical formula, and we're given grams. So let's title this example that, because you might need to come back to it. Find the empirical formula given masses or given grams. You're going to have to do problems like this when you go to do your CK12 work, so you want to be able to find the example. All right, so what am I given? I'm given 13.5 grams of calcium. I'm given 10.8 grams of oxygen, and I'm given 0.675 grams of hydrogen. What is the empirical formula? All right. So because we have different elements, we can't really just compare the grams. So you want to make a note of that. You can only compare moles. You can only, because moles give us the number of atoms. So we need our roadmap. Remember our roadmap that we had? Mole roadmap. Okay, so if we're given grams, we're going to find that. We're given a mass in grams, and we want to get to moles. So mass in grams, 2 moles. We're going to use 1 mole over the molar mass for each of these elements. That's the first thing that we're going to look at. So we need to know how many moles each of them have. I'm just going to start right here. I have calcium, I have oxygen, and I have hydrogen. So 13.5 grams of calcium. And I know from my roadmap, I'm going to have 1 mole on the top and the molar mass on the bottom. Where do I find the molar mass of calcium? It's a lot of going back to your references. You find the molar mass of an element by coming to the periodic table. So 40.07, which would be 40.1. Okay. And so because there's just a 1, we're going to just divide 13.5 divided by 40.1 equals 0.337 moles of calcium. Then I got to do the same thing for oxygen and hydrogen, so let's do that. 10.8 grams times, we're using the same formula because we're given grams, so we want the same conversion. So we're going to go 1 mole on the top And then the molar mass of oxygen, which by now we probably have memorized, 16.0 grams. Right, so we're going to say 10.8 divided by 16.0 gives me 0.675 moles of oxygen. And then hydrogen, we have same conversion we're going to use. So this time hydrogen is only 1.0. So that's easy. The number divided by 1 is just itself. All right. Got a bunch of decimal points. Ah! Okay. Here's the trick. Divide the big ones by the little one. Fancy math, right? So find the smallest one. It's this one. And you're going to divide all of the other big ones by the smallest one. We should probably write that down. Okay. So I don't know where to write it up. Here. Yes. Big numbers by the smallest number of moles. And so what that does is that makes your smallest number 1. Okay. When I bring my calculator into play and I say, bring my calculator into play, I'm going to say 6.675 divided by 0.337 equals, well, look at that. It rounds off almost perfectly to 2. So that means, and conveniently on this problem, I have the same number. So 0.675 divided by the 0.337. So the big number divided by the small number is still going to be 2. All right, so after all that math, what was I supposed to find again? Find the empirical formula. So I'm going to find out how do these elements go together in a compound. And all I have to do now is take my element and make this number, this ratio, my subscript. So my formula is Ca1 because it was the smallest number, and I don't really need the 1, but we'll put it there for right now. O2 H2. Now, that is fine. That will totally work. But if you remember, we know that OH is a group that usually comes together. So we could also write it CaOH and employ our parentheses because they both have 2. So both of these would be correct for our purposes, right? Now, CK12 will only take the best one, but I will take either one, okay? Take a deep breath. Does that make sense? Some people are like, yeah, some people are still staring at the screen going, oh my gosh. It's a lot of steps. So let's digest that. What are the steps that we went through? First one is, what did we do first? First of all, we had to find the number of moles that we had. So that's the first thing. So the first step, find the number of moles that you have from the masses. What was the second thing we did? we had to determine our ratio. So, like, that's the complicated way to say it, really. We're going to say determine the ratio by dividing the big number by the small number. And the last thing that we did, what time do we leave here? Oh, the last thing that we did was we'll say answers from number 2. Subscripts for your elements. All right, and it is 11:20. We will leave at 11:25. So we'll stop there. Okay, for today. You guys don't have to submit anything. It looks like we're going to have to make today a 2-day lesson because there's a lot more stuff we need to go into. Okay, but you don't have to submit anything today, just because we'll finish it tomorrow then. But just make sure that you have these notes in your notebook so that we can continue them tomorrow. Okay.